I didn't hear what that said. Oh, let me turn on my speaker. Find me. So I'm trying to, thank you. That one, set. That turn on, good. Right. Let's see, we had this last time. We got some people on. All right, are there any questions? Online or WebEx people, let me know if you can hear me. I had some issues with the sound.
I can hear you, Professor.
Thank you. All righty. Are there any questions? Any problems that you would like me to do? No dice? Okay. I think we're doing 2, A and B today. More exponents. Oh, and I want to give an update on what we're going to do in this class for the rest of the semester. This class is so tightly packed that I think I missed one day and I have to adjust the schedule because of it. So let me see what we have here. Most today. Here's how the rest of the semester is going to shake out. We're going to do this stuff on exponents this week, and that'll be all the material we do. So today we're scheduled to do these two. These are all exponents. And Wednesday, so then next Monday, that'll be review. And a week. So you'll have test for them week from Wednesday. Okay. So there's not a lot of material. It's all going to be exponents. Just the stuff in chapter 2. That's all the test is going to be. I'll make up homework for it while we do this, but most of it, as usual, I do a little explaining and then we do like, I don't know, a million problems. So let me see if I can find something from 2.2. All right, previous class, we did something like this. We looked at quantities, say, to the squared or maybe all sorts of things like this. Things we did not consider yet are the following. What would this be? What if we allow the exponents to be negative? What would happen then? Yeah, we have things to work with there. Let's take a look at what was the one thing that we had. We had a rule. It all fits together. But we had some sort of a rule that looks like this. If I wanted to do x squared times x to the -2, what did we do with those exponents? If you have the same base, then you could, in fact, add these exponents together, couldn't you? Two plus -2 is this. So we have to talk about raising things to the 0 power before I can do the negatives, is all I'm saying. So we have to figure out what that thing is. But let's do, I don't know if I'm going to establish that one first or not. It's given as a definition. All right. This is the definition. It's not a big beat. So you can try this on your calculator. See, try doing any number that's not 0 and raising it to the 0 power and see that it doesn't give you a 1. I really don't care. And then try 0 to 0 and see if it doesn't give you an error message. Let's see if I try 0 to the 0 power. I don't know if you guys can see this or not. What's that? You get, is that what it says? Domain error. Means it will not do it. But any other number, if you raise it to the 0, what you get? 1. All right, so we have this as a definition. So let's come back. So this thing here is equal to 1. This means this is a bit complicated sounding, but you remember a phrase that they used to use years ago, maybe when you were in elementary school, but you might have heard the phrase, multiplicative inverse or additive inverse, things like that. Multiplicative inverse, whenever two things multiply together to give you a 1, they're inverses of each other. So I'm gonna take this last equation that we have here and do some. Since I have this here, what I'm gonna do is divide both sides by x to the second power. I'm assuming x is not 0. So this cancels here and here. So this tells you what the negative does. It makes, like you said, it makes a fraction. In fact, the rule looks like this. If I have anything raised to a negative power, I can rewrite it like this. I don't remember what the name of it is. I just call it negative exponent rule. Note that, make sure you always keep this in mind with any of these fractions like this. They divide by 0, so that's why x cannot equal 0 on any of these things. On a series of numbers, when I say evaluate, I would like to rewrite them without the exponent. So I'll show you the first example that I have in mind here. Suppose I take -4, raise it to the 0 power. What are you going to get when you do that? You should get 1 because that -4 is not equal to 0. So 1 is what they're talking about. So if I give you something like this, 9 raised to the -2nd power, what do you think they're looking for you to give them? What can we do? That -2 is bothersome. We can unnegative it by doing this, can't we? And then, what's 9 times 9? So this is what they're expecting you to write for the answer. How about this one? It's to the -2. First thing I would do is use the fraction. Like so. And 10 to the 2nd power, everybody knows that's 100, right? Take a few minutes to try this. Don't write a decimal down, whatever you do. Just don't let your calculator give a decimal to it. Make sure that you write your answer as a fraction if necessary.
So, Professor, is it always going to be a fraction? Like every single time?
When it's a negative exponent, it will be.
Got you.
So we got, and I think the calculator would do it straight up if you just type 2 to the -5. Let's see what happens. That didn't work. Yeah, we went over 32, but let me see what happens. Okay, let me show the guys on the screen. This is what happens if you try to do, I don't know if you can see this or not. Hard because I have to angle it strangely. Can you guys see that? Gives me a decimal. And I don't want that. How do you fix it? There is a button for that, isn't there? In the PRB, in the PRB button? There is a, there, it, I'm sorry, say again? Oh, second. Yeah, that's the F to D. Gotcha. Let me clear out of this. We'll see if it's still in there. Yep, it'll do it. All right. Obviously, don't let your calculator be your boss though. You need to know how to do them because what we are gonna move is these numbers are gonna be replaced by variables. Eventually, then calculator will not be very helpful. These types of problems. So you need to be able to do this process. Of course, 2 to the 5th power is 32. What about this one? One of the rules we had from the last time was that that -2 can be applied to each number inside. Now check this one out. We know that 1 to the -2 equals 1 over 1 squared. Is that equal? One squared to the 1.
I was thinking about
This is just 1, isn't it?
yes.
All right, what about 10 to the -2? That's 1 over 10 squared, which is. So how do we reckon this? Here's what happens. I'm going to write this as big compound fraction. So I've made all the exponents are now positive. Now you might remember fractions. You have a fraction divided by a fraction. How do you work it? You turn the bottom fraction upside down. Multiply. That's a lot of work for that. I'm going to show you something that I think will make it a little bit. Check this out. Problem again. Cause everybody absorbs that. You understand why it. Oh, actually, you know what? Better than that, let me do this. Look at the fraction inside. What happened to it? Flipped it, but look at the exponent. That's right. Now look, the exponent is positive. Now we can do 10 to the 2nd power divided by 1 to the 2nd power, and that's equal to 100 over 1. So our goal here is to practice these things. We're going to give you a bunch of them with negative exponents and expect you to work it so that the end result will have positive exponents. So you can always take negative exponents and make them positive. Let me do another example. Let's type. Let's do 2/5. Usually called to write your answer so that it does not have a negative exponent. So for that practice, what was the step that I did last time? What am I going to do to this, you think? flip the fraction, but then when I do the exponent. Positive. Like that. Now, it's easy, you can do 5 raised to the third power, divided by 2 raised to the third power. You know what 5 to the third is? 5 it is, and 2 to the third? 8. 10. Anybody get it? Over 100? Flip it. First, 3 over 10. Raise that to the second power. Now, by the way, have you wondered if any of these fractions are able to be simplified?
Start round up.
If-
You're going for it.
If they could be simplified, you would be able to do it right now.
All right.
So I'll raise each of these to the second power, and as you said, we get 9 over 100. If you get in the same vibe with these things, you'll be good, but they can be tricky and slippery. You gotta watch.
Say 4/10 or 4/10 or 5.
Let's do it. Let's do, I'll make one up. So we'll do 10. And we'll raise it to the negative 3 power. So we'll then upside down and raise it to the third power. Now, do you want me to simplify first, or you want me to do it both ways so that you can see that it is actually what I say? Simplify first. So what goes into both of these numbers?
2.
So I'll be looking at 2 over a 5, right? So in 2/5, I'm going to rewrite it to the third power. And so I can do 2 to the third over 5 to the third. And that will be 8 over 125. Now, I said before, if you want me to actually do this out, leave it as 4/10 and do it to prove to you that I get the same thing, or do you believe me? All right. Now for some of the annoying ones. You'll see what I mean as soon as I throw them up. All right, this is evaluation. Negative. Anybody think they got it? Cheap. You, I don't care if you're cheap, but anybody think they got it? Not a lot of confidence in this room right now. Let me ask you, before you do anything, what should you do? What should you attend to first? That negative or that exponent? Exponent, because the exponent is more important than subtraction. So I can rewrite this as negative 1 over 4. That So it handled the exponent, the negative part of it at least. And now I can just simplify it. Negative 1/64. They saved these really annoying ones for the end. So the rule is just evaluate. Tell me what this number is equal to. This one is like almost identical. We saw. -1/81, that's correct. First step is to recognize you do the minus or negative first. And second, to have 9 to the second power. And then all I have to do is evaluate that. This uses a combination of rules. Yep, it's 29/100. So the first thing is, that's before you get the exponent, before you do the addition. And get my exponents done. Right now, in order to add these fractions, we need a lowest common denominator. LCD here, be 100, that's 4 times 25. So I'll write this first one as 4/100, and the other one is 25/100. Let me pause. Do you guys understand how I got those? First fraction I had to multiply by 4, second fraction I had to multiply by 25. Now, since they have the same denominators, you can see it's starting to get slippery. You can see it. Check out this next one. Now, 4 and then minus 6 to the -2. What'd you get?
So that's-
I didn't get that. I got 518. Let's take a look. Exactly. You were wrong. So we have one credit card is not so good. Okay, where are we? So we have 1/4. Let me write this step here. I ended up adding, not thinking about the negative step. 1/4 minus 1/36. The LCD is 36 since 4 actually goes into 36. So I can rewrite this as 9/36 minus 1/36, which is 8/36. And we can now divide by 4. 4 goes into 8 twice, and 4 goes into 36 9 times. So we got 2/9. How about this one? I think I can write that one. How about -9 to the 0?
So -1.
It'll be -1 because you do the exponent first. However, if I tell you this part, what happens if I do that to you?
So be 1.
That does equal 1 because the whole number is raised to the 0 power. This is the kind of stuff that people can't stand about these things.
Correct.
Everything is fine and dandy until you get to like negative numbers and fractions and things. And it's no fun. Yeah, this one is the last of these style of problems. We have 6 to the 0, so it's any kind of weird. -9 to the negative plus 4 to the 0 plus 3. Oh, yeah. So for 6 to the 0, that is 1. It's 1 over 1 plus 1 over second. It's 190 plus 1 plus 1. So you saw that this -1 might cancel with that one. And you're left with 2. Any questions in WebEx land? So,
I like that one. That was kind of easy.
okay, well, that got a little bit, I don't know. Could be there, I mean. All right, so what we're gonna do, let's move on to 2.2b. This is where it gets more complicated. Because we're going to now allow bases to be variable. Section. Stated. all variable. Zero. No, we don't have to worry about dividing by them or anything. Without worrying. Try to see what we can do when we don't have numbers available to us. What's available? What are the things that we can do in general without actually having to know what number is involved? So I'll show you what I mean. The rule is always positive exponents. Now, I want to be clear about something. Positive exponents is just an exercise. That doesn't mean that the problem is written with negative exponents. That doesn't mean that that problem was wrong. It's okay to have negative exponents. I'm saying for this, for practice, they're going to require you to make all the exponents positive. So I'll show you the first example. Y to the negative 7. So you don't know the value of y. But at least you can apply the one rule that we have and take the negative away, the exponent. So your final answer will look like this. Since I can't do anything about it, not knowing what the value of y is. That's my answer. That has positive exponents. Knowing that y is not equal to 0 means that I don't have a problem dividing by it. So what are some of the things that we can do? For example, you have this one here. Okay, I don't know what it is. All I can really do is this. That's the game for this whole section. Rewriting with positive exponents only. So let me just throw up what we're going to do. There's a million examples. Here we have h raised to the negative power divided by k. Let you guys give it a minute or two, see if it works out. And then I'll do it. Anyway, think they got it? H squared times k? No. Let's do this. We have 1 over h squared. That superfraction is a superfraction. Do you agree with this? That's how you take out the negatives initially. The reason I'm doing this problem is to show you what will amount to something easier to do. When you have a fraction divided by a fraction, you turn the bottom fraction upside down. You multiply it, right? You don't have to write that 1 there, but I want it there just to show you something. You don't have, well, now when you multiply fractions, you multiply across. So I get k raised to the 1 divided by h to the 2nd. So let me write this here. Look at those exponents. It looks like all I did was swap positions, doesn't it? That's exactly what it is. If you, as long as the one in the numerator goes down to the denominator, x exponent becomes positive. The same for the ones in the denominator. When they come up top, they'll become positive. You can write the answer this way, it's perfectly fine. Although if you look in the back, I almost certainly can guarantee that they will not put that one up there. So the reason I want to do this one is because look, immediately, if you're given a problem like this, so this is the problem you're given, you can immediately then take out the negative exponents, then do some simplifying if you have to. So step one, wipe those negatives out and then you're halfway home. All right, one, just like here, we're going to have b to the negative 2 divided by w to the negative 7. This now what I showed you, this should be a one-step problem. Because all you have to do is swap them. W to the 7th power. B to the positive 2. That's, so we can use that now from now on. That's a nice, huge shortcut for these problems. Now, as you know, and I always say this, you know, we're going to start mixing stuff up. This next example is exactly what I'm talking about. Here, 9x to the negative. Some negative exponents and some positive exponents mixed in. Anybody think they got it?
So one of them. So it won't be a fraction.
It'll still be a fraction, of course. Yes, yes. You won't clean it up.
So it won't like. So will it squared?
Not quite. Not quite. Show you the detail of why. Watch this. Deconstruct it for a minute, if you don't mind. Really, that's true. All I did was pull it out. The reason I'm going to do that is because next I'm going to do this. Still. So far, so good. Now I'm multiplying together. 9, so the 9 is still on top. I'll put it in alphabetical order, although there's absolutely going to read. Let me re-put the original problem up here. See if you can visualize what actually was the one thing that happened here. look at that x to the negative two. What happened actually? What is the net effect of this? What happened to that negative two? What happened to that thing? It's down in the denominator, isn't it? But it's positive. So all I had to do was move the x to the negative two down there. The 9 wasn't affected. Because that 9 didn't have any exponent, did it? No negative exponent for sure. So that's really, if you look at it, it's just one step. X to the negative 2 simply went into the denominator and became positive. So I've given you the basics for the rest of the problems. All the rest of them are practice. They're harder, more complicated problems. But we'll do as many as I can before the class is over. Let's go ahead and take a 10-minute break there. Probably enough, I think. All right, back to the garage. Everything I know, everything that appears up here, you have rules and things to handle them. They're just gonna look weird. So remember, all of these problems, they want you to rewrite the answer with only positive exponents. But it's just an exercise. It's simplifying, I suppose. You're given that, and you're asked to rewrite that using positive exponents only.
So we simplify to like the third or 8 to the 4.
That's one way. So if they might ask you to simplify more, but you've done what they've asked. You've made all the exponents on. One way to look at this is probably think of it this way. Agree with that? Now I'm just going to multiply across. B to the third. 9, 8. That's probably the way the answer is going to look in the back. Well, you know, when it tells you the answer, it'll probably be that. What happened though, if you look, all that happened was that negative exponent simply went down to the denominator, didn't it? And, I mean, there's a lot of fanfare here for a little bit of work. All right, let's see how it's coming for you then. With the next one, all these are the same deal. You're just with positive exponents. 7. 2t times u7. I'm gonna start pulling them out of the textbook. It's easier than writing them out. All right, what happened here? It should have really been a one-step problem. Right to U2. Remember, the number stays, the number didn't have an exponent, did it? Or well, it has the exponent of 1. But the only thing that has to move is the t, right? Just change position so that it becomes a positive exponent. 7r t to the 9th power. Now it's in the numerator. What's left in the denominator? 2u squared. So far, so good. Wait, we're on 2.2. They get rather interesting. What variables are moving? Let me ask that. Right, so C and B are the only things where action is happening, right? Those are the guys that aren't moving anywhere. B to the 1 comes down here. C to the 10. Yeah, they may on the bottom, they may put the B first, just for alphabetical purpose. So you get these, they do get someone okay. You're just moving the things that have negative exponents. Everything else stays put. If I would have showed you this at the beginning of class and said you're going to do this before the end of class, you would have probably been like, no, I don't think so. But it's really not that bad. Let me grab. Did I block my thing? Yes, I did. Out of there. Get out. What variables did the moving? The K and the M and the M, right?
Square.
Here's what I do. And so I wrote down all the things that I know aren't gonna move. Now I'll finish it off. I know the M comes up top, right? The N also comes up top. And the denominator. Negatives. So what variables are doing moving now?
Thanks.
X and Y are moving. All right, so they move, what do they leave in their wake? That's the good question. What do they leave in it down there? That's correct. So we have, I'll write it as I normally do, I'll write my things with positive exponents already. Now the X to the 7 comes to the top, Y to the 6 comes to the bottom. What is left down there? You took everything away. You can't divide by nothing, so you left it 1. Or most likely, if you were to look at the answer in the book, they're gonna have this. You don't have to write the 1. So that's most likely what the answer is gonna be. But both of them are right. So you can see the game, we're just playing around a little bit, trying to, I don't know how you put it, but try to make sure we cover every little last weirdness that can happen. That you're exposed to everything that could possibly happen. That one.
Square C.
That's it. You just move those things up to the top and that'll do it. And you can write C to the 1 if you want to, but that'll work.
6 over a squared.
36, excellent. So we just flip it upside down to take out the negative. We got 6 over a, now let's raise to a positive 2. That's 6 squared over a squared. And as you said, that's 36 squared. So this particular combination of numbers and letters didn't present a problem at all. Let's grab something a little more complicated then. Let's grab number 30.
Same deal, squared from WW to the third.
All right, say it again.
15V to W over W.
15V. Check your 15. I think you did 3 times 5 accidentally.
Yeah.
5 to the third is 125,
Yeah.
but you didn't raise the V to the third power.
So the B is still you raise to the third.
Everything is. Remember, that's one of the rules, is that every single thing in the, inside of the parentheses is gonna get raised to the third power. Right, 5 times V, so we can flip it and take out the negative on the 3. 5V over W raised to the positive 3. Yes, and now you take everything to the third power. So I have 5 cubed, V cubed, W cubed. 5 to the third power is 125. And the other things stay there. Any questions? All right. If you want to practice, these odd ones have the answers right there.
To the 6 over 64 T6 6.
U6, well, that's U.
Let's see.
Doesn't
Oh
matter,
yeah,
right?
it's TU. Go to 6 power and use the 6 power.
Right. So you flipped everything upside down. We got V over 2T. Now it's raised to the positive 6. V to the 6th. 2 to the 6th. B to the 6th. 6th. The only thing I can do anything with the 2. 2 to the 6th power is 64. Let's see if there's any trickiness left in here. Oh, there is. I know some. These ones are always cause weird. They look so simple, but they cause weird reactions from students. I'll throw it over here.
So would it be 1/243? 243
Nope. Well, let's take. And if you don't remember, this is one thing. Keep in mind, you're applying the exponent to the number as well. And this is really 3 times g to the -5. Right?
Yeah.
This is 3 times 1/g to the 5th. I think it'd be better to write the 3 as 3/1 to make this multiplication compatible. And so I'll get 3/g.
Oh, okay. I had it right in my head, but wrote it the wrong way.
Well, just don't let these simple ones scare you. There's something weird about it. It's so simple looking, isn't it?
Yeah, a little too simple looking.
There's something annoying about it because it's so simple looking. So let's go ahead and, since this I see causes a little bit of issue, let's try next one that's just like it. But I mean, the goal is when I give you a problem like this, you should just be able to write down the answer as one step, you know? That would be the hope. H to the 4th power. That's right. So you should be, it would be nice if you were able to go like this. Be done with it. That's perfect. So another couple annoying ones, and then we'll go on to the trickiest ones. So let me find another annoying one. Here, this one will cause some unhappiness. Negatives are always here to destroy the party.
So -1.
That's right, -1/d to the 5th power. That's correct. Exactly right. And probably the easiest way to see this is if you rewrite this as -1 times d to the -5. If that helps you, then you can immediately go to -1/d to the 5th. And notice that they have a negative in the answer, but that negative is okay because it's not an exponent. What happens when people get too many exponents, they get overwhelmed and they start, like some of the things that you've said today, they start losing track of things, I believe. This one should be fairly easy, but we'll see.
the sixth power over 1 to 6.
That's right, k to the sixth over 1 to the sixth. You can even simplify that.
6/1.
K over 1, sixth. K to the sixth over 1 to the sixth, even better than that. Over 1, there's no big deal, right? And then now for the final piece of this. Yeah, this is what they're heading to here, a little mixture of these things. And it's always, it's the biggest mistake students are making is some of the things I've heard you say where they get the exponent mixed up with the number portion. And that number is not to the eighth or negative eighth power, it's by itself.
So 7t to the 8th.
7t to the eighth power, that's exactly right. Are you putting the times and putting there to help yourself?
Nah, I always see it there, but it.
All right, as long as, like, whatever you need to do. Let me tell you something, I was born with something of a reading disability, wherein I have to sound out all the words when I read them. That's how it is for me. You know, most people can just go and read without having to do that, so I'm slow at it. The point is, as long as we get to the same thing, I don't care how we get there. My comprehension is plenty good, so I don't mind being a slow person. But then, as long as you can get to something like that, in whatever way you need to, that's fine. We'll do things probably in different orders.
All right. I got dyslexia.
All right, now for the weirdest ones. The end of the section, as usual. Let's do. These may seem sort of weird. Try this one. 2 by 2.
Those are 1t to the 5th.
Yes, good job. That one I thought was going to be tricky, but you realize, funny is the book has it wrong here. You recognize that multiplication there? You did, then 2 divided by 2 is just 1. Multiply together. But well, I guess I'm telling you, you actually have to do something in your problem. So this one is divide. We have 6x to the 5th divided by 7 divided by 6x to the 8th divided by 7. So simplify it, and if you need to, write the answer with a positive exponent, with positive exponents. X to the fifth over X to the eighth, that's what, right? We can simplify that. First step was to flip the second fraction, am I correct? 6x to the fifth, 7 times 7 over 6x to the eighth. And you can do all these cancelings, like the sevens will cancel. It leaves 1. The 6's cancel. It's in those places. And all we have left is x to the fifth. I suppose that can be simplified at all.
So,
We're not going to inquire into that right now, but I can do this trick. All and such. Took that x to the eighth and broke it up in a very, very interesting way. Why would I choose that way, do you think?
it's not
What's left in the numerator?
the
No, in the numerator.
oh, no, 1 is the third.
Positive exponent too. That was tricky. Usually I would have trick like that. People seem to remember it because it so stands out so ridiculously.
Yeah, and I'm sitting there like, look at
That's the gist. Well, you are, of course, you're allowed to. Any identity that we have, you're allowed to go the opposite direction. They all work left to both ways. No, there's a q squared in there. Yes, yes. And a p squared. The 9, I think you screwed up on. So let's take a look what we have. Now, try to dismantle it in your brain as necessary too. So I'm going to get rid of my negative exponents inside and first. I'm going to write the 3 as 3 over 1. Then the q to the negative 1 is 1. we handle the division because it comes first. Flip the second fraction, so 1/3 times 1/2, all that raised to the -2 power. So now you see that you can put the fractions all together into one. It's common to write the number part of it first, so I'm going to write 1, 2. So I had to do several steps just to get it to a recognizable state. Now I can take out the -2 up there by flipping that fraction. Heck, you know, I never even thought about it. I could drop the 1 right now, couldn't I? Squared, squared, u squared. And if you want to square out the 3, that's fine with me. I don't know if they require it or not. See how we do. This could be the last one, okay? It's like it. Similar. H to the -2. Or all of that. And then when you get comfortable with this, you'll be ready for the class on Wednesday is going to be a blast. And it's going to be cold outside, so you don't have to stay home. K to the 4th is in the denominator?
Yes.
Good job. Yep, that's exactly right. You can back up. How many of this just for the audience at home? the second power. The 1 squared is just 1.
Take put it on 16 on
Okay. And so this is, if you get good at this, you'll be prepared for next time, because that's what we're gonna do the hardcore rules. These
Just
things.
to make sure I got it correct, that the two squared on the outside was being.
Say again, I'm sorry, I didn't hear you. Say again.
Just to make sure I got this right, the 2 squared on the outside was being multiplied by the two on the H and the K, right?
Yeah, that's right, yes.
My mind was like, this could be 4, this 2 plus or 2 times.
It's 2 times, yeah. Well, that's the problem with 2s.
Yeah.
All right, that's all.
Let's see what it's like.
See ya.